Black holes are some of the most fascinating, mysterious, and downright strange objects in the universe. They have such strong gravitational pull that anything that gets sucked into a black hole disappears forever. Even light cannot escape the clutches of a black hole. We know that nothing ever comes out of a black hole, but what happens to the stuff that does fall in? What's actually inside a black hole? Scientists have long been fascinated with black holes. The existence of objects with gravitational fields too strong for light to escape has been theorized about the greatest scientific minds since as far back as the 18th century. After Einstein developed his revolutionary theory of general relativity in 1915, scientists finally had a way to calculate and describe the phenomenon of a region of space from which nothing can escape. Still, the existence of black holes remained a mere mathematical curiosity until the 1960s, when Stephen Hawking popularized the concept. Until very recently, the only way we've been able to find black holes is by combing the skies for the telltale signs of their interactions with nearby objects. Gases and stars near a black hole behave differently than elsewhere in the universe, affected by the black hole's gravity and giving off a high-energy light invisible to the naked eye but detectable with telescopes using special tools. Through reverberation mapping, scientists can measure the radiation thrown off by a rotating disk of debris around a black hole and pinpoint its location, even if they can't see the black hole itself. Then, in 2019, scientists did something that was previously thought to be impossible. They captured an image of a black hole using the International Event Horizon Telescope. Finally, the world had solid photographic proof of the existence of black holes. Technically, what they captured was the black hole's shadow, since the black hole itself does not reflect any light, but nevertheless, it was a major breakthrough that would have thrilled Einstein just a century ago. Despite our inability to get near one or even to see one with our own eyes, thanks to the tireless and groundbreaking work of mathematicians and theoretical physicists, we've been able to learn quite a lot about the formation, properties, and behavior of black holes, even before we were able to view them with the help of technology. A black hole is a place in space where the force of gravity is so strong that nothing can escape from it, not even light. The gravitational pull is so strong because in a black hole, all matter has been squeezed into an inconceivably tiny space. Mass refers to the amount of matter or stuff in an object. The smallest black holes, which were believed to have been created at the time the universe began, might be as small as a single atom, but they have the same mass as a large mountain. Stellar black holes, created when the center of a large star collapses in on itself in a supernova, can have a mass up to 20 times greater than our Sun. The largest ones, called supermassive black holes, have masses greater than 1,000,000 of our suns and lie at the center of every galaxy in the universe. The supermassive black hole at the center of our Milky Way galaxy, Sagittarius A, has as much mass as 4 million of our suns, all condensed into only a ball as big as a few million Earths. If our sun were somehow replaced by a black hole with the same exact mass, would the Earth be in danger of falling into the black hole, never to be seen again? The black hole's gravitational pull would be identical to the sun's, despite the fact that it would be much smaller. The Earth and the rest of the solar system would continue to orbit the black hole the same way they orbited the sun, though without the heat and warmth they're used to from the sun. Thankfully, our sun is not massive enough to collapse into a black hole, so it's not something we have to worry about. If we're able to know so much about how black holes form and what happens around them without having visited or even seen one, can we possibly have any clue what's actually inside a black hole? Though it would seem impossible for anyone who somehow made it into a black hole to report back to us, scientists do have some pretty good ideas about what goes on inside a black hole. The closest black hole to Earth is more than 1,000 light years away, so unfortunately, it doesn't look like we'll be sending any exploratory missions there anytime soon. But if we could, what would we find out? What would the first brave explorers see inside a black hole? Anyone brave enough to get near a black hole wouldn't actually be able to see it as they approached. The objects outside of the black hole can fall into it, effectively impacting whatever is inside, but the black hole cannot affect the exterior universe because its gravitational pull is so strong that anything sucked inside, including light, can never escape. If light cannot escape, there is nothing for our eyes to see when we look at a black hole. Instead, explorers approaching the black hole would have to be on the lookout for the cloud of gas and debris orbiting it to know they're close. As the brave explorers drew closer and closer to the black hole, they would notice a threshold beyond which there is nothing but an empty, black nothingness. This is the event horizon, the black hole's last frontier and the point of no return. A black hole itself is a singularity, a point of infinite density, where all matter has been squeezed into an infinitely tiny space and the laws of physics cease to apply. The singularity is shrouded from view by the event horizon, what we would consider to be the surface of the black hole, though it's not a surface in the true sense of a word. The event horizon is not a real physical barrier or a membrane, but rather it's an invisible barrier at a particular distance from the singularity, a threshold beyond which the gravitational pull is so strong that nothing, not even light, can escape. Once something or someone has crossed the event horizon, there is no going back. Once they've pierced the veil, they'll begin the long fall toward the singularity, the ultimate one-way trip. The fall into the black hole wouldn't be instant. A brave explorer would have a few moments to enjoy the experience. The time it takes to reach the singularity after crossing the event horizon depends on the size of the black hole. In the smallest of black holes, like one the size of a few of our suns, it would take less than an eye blink to reach the singularity. But in a massive one, millions of times larger than the sun, the explorers would have a few heartbeats in which to take in their surroundings. What they would see and experience in those few brief seconds would seem like something straight out of a sci-fi movie. In the universe outside of a black hole, objects and people are free to move in any direction they choose, up, down, left, right, backwards, or forwards. But they are always moving forward through time. Inside the event horizon, though, there is no other option but to travel toward the singularity. Inside a black hole, the singularity is the future, and all matter that falls into a black hole must simply travel toward it. No matter which direction someone in a black hole is traveling or which way they turn, the singularity is somehow always right in front of them, while at the same time always out of sight. As the daring explorer falls forward beyond the event horizon and is drawn toward the singularity, they would find that the space around them is anything but black. In fact, they'd be completely enveloped in light from the surrounding universe, light that crossed the event horizon and is falling toward the black hole along with them, doomed never to escape. The extreme gravitational forces inside the event horizon would bend and twist the light as it gets pulled toward the singularity. Those same gravitational forces would be hard at work on the explorer's body too. The black hole's tidal forces would exert different amounts of gravitational pull on different parts of the body, squeezing it at the midsection and pulling and stretching from end to end, in a process appropriately dubbed spaghettification. As the explorer's body is stretched, infalling light would be concentrated into a band of light wrapped around their waist, until both body and light lose all dimensionality. If the heroic explorer could peel their eyes away from their body's physics-defying acrobatics, they would witness another strange phenomenon: time dilation. The universe they left behind beyond the event horizon would still be there, but would appear to have sped up and be moving much faster than the time inside of the black hole. But to anyone looking on from the outside, they would see something much different. To them, as the explorer began to approach the event horizon, they would have appeared to move slower and slower, and it would look like they'd never crossed the event horizon or fell into the black hole at all. When the falling explorer finally catches a glimpse of the singularity, they would see, well, nothing. Reaching the singularity would feel like landing on the surface of an enormous, empty, featureless black planet stretching from horizon to horizon. The explorer's body, by now distorted beyond all dimensionality, would be crushed into a tiny ball of infinite density before dissolving irrevocably into the singularity, never to be seen or heard from again. All that they've seen and all they've experienced inside the black hole would be dissolved with them, lost to us forever. Those on the outside could certainly attempt to send signals into the black hole, but those signals would only join the explorer's body in the singularity. Even if someone inside a black hole could somehow receive the signals and attempt to reply, the black hole's intense gravity would ensure that no information would be able to escape the black hole. At least whatever dirty secrets the explorer took into the black hole with them would be safe forever. It's truly awe-inspiring to realize that we've only recently gotten photographic proof of a phenomenon that's been theorized about for centuries and mathematically proven for 100 years. Even more incredible is the fact that as much as we know about black holes, we have yet to see inside one. Everything we think we know about what's actually inside a black hole is still purely mathematical theory and conjecture until we can figure out how to get a real look inside and live to tell the tale. That doesn't seem likely anytime soon, but science continues to surprise us, so we might just find out sooner than we think. If this video hasn't scared you off of space exploration, you'll have to check out what it takes to join Space Force. Or if you prefer to remain on terra firma, you'll like this other video instead.